Hello viewers, Alan here. Thanks for joining me in the workshop again. In this video I'm going to be making a gutsy forcing screw from some scrap hydraulic piston rod. These things are typically, well, they are high tensile steel and they're typically 4140 I believe. And they can be quite a cheap source of material for machining projects. In fact, I've been able to scrounge what I need from a local scrap bin with the owner's permission, and he usually pretty much gives them, and sometimes actually gives them to me. So the price is certainly right. However, these things are pretty tough, and in this project I'll show some of the issues that I face in working with material, and I thought I'd do it through a real example rather than just talking about it. So, to the real example, a friend of mine gave me this kit recently. It's a bearing front wheel drive bearing service kit, and it's missing an important part, the forcing screw. So in this video we'll make a replacement. Well, better get started, hadn't I? So the material I want to use for this project is a short piece of a hydraulic cylinder rod. It's 1 inch diameter, and it decided it'd rather look like a banana, which rendered it useless for a hydraulic cylinder rod. Anyway, I've given it a rough straightening, and now I've cut this short piece out to use, and I want to see if I can get it a little bit better. So just to show you in a bit closer the amount that it's out. That's it about there, I think. So I think the bend at this end is about 2 millimeters, so it's not terrible. I'll give it a bit more. Okay, well that's looking pretty close now. Close enough I reckon anyway, because the OD at the moment is 25.4 and what I need for my workpiece will be 22, so I think I'll get 22 out of that without any trouble. Let's go and put it in the lathe and see what it looks like. Well, that doesn't seem too bad. I'll put a couple of centres in the ends and get it mounted up, and then we can check it out properly. Alright, so I've got this thing mounted. Let's just see how it turns mounted like that. Well, that seems pretty good. So first job is to get rid of the chrome and the induction hardening layer. So it's 25.4 OD. I'll try doing a pass at 25 and we'll see how that goes. Let's try it to 24, 1.5 millimeter depth of cut. Yeah, that's not cutting. I'll have to change the, I think I'll turn the insert around. Now I dare say that'll have a bit of heat in it. We'll just have a quick check on how things were going. I was shooting for 24, I've got 24.16 there. .19 there. .17 there, so that's pretty good. So that first pass was with a 1.5 millimeter depth of cut, but there's quite a long way between centres here, or between supports, so I think I'll do my next one at a millimetre depth of cut and try to get this to 23 millimetres. So that pass was set on 23 and we're slightly over that, but it's got a bit of heat in it at the moment, so that might well come back to being pretty close to the mark. So I'm going to stop there and let it cool down. Okay, so I've got this bar down to 23 millimeters. I want 22 and I'll be threading it at full length, so I'm really not that fussed about the surface finish. So I'll set for 22 run a little bit and see what we get, and if it's alright we'll keep going. Righto, well, let's see how close we got to 22 after all that. Well, I guess that's pretty close, 22,005. Alright, certainly close enough for cutting the thread on. So, I think put a good chamfer on here and start cutting the thread. So according to the engineer's black book, the minor diameter for M22 1.5 is 20.16. So I'll do a 20.16 undercut here, so I've got something to run the cutter out into. So I think that should do us. I think we're down to 20.1 now. Yeah, so that'll do. Ready to get going. I think with my first pass I'll go 0.5 millimeters in and we'll see how that works out. Now my lead screw has a 6mm pitch and I'm doing 1.5mm pitch here, and because the lead screw is a multiple of the thread I'm cutting, I don't need to use the thread chaser. I can start and engage the half nuts anywhere on the lead screw. So we go back in for our second cut, 21.2 this time I think. And run back to the start to repeat the process. Right, well I think that finished the final cut, so I'll clean some of this swarf off and do a test fit with the nut. Hopefully it'll fit. I was thinking as I was cutting this, it's entirely possible that the act of cutting the thread would cause stress to be relieved in this thing and for it to try and resume its banana shape. Oh, that's pretty good, isn't it? Not much movement there. Alright, I've got to see if it runs all the way along, I suppose. It's getting a bit tighter in the middle here because it's possible this would deflect. Definitely getting tighter there, tight spot. So on reflection I decided that I've never used this travelling steady, but I thought if I was ever going to use it, this looks like a job for it. So perhaps belatedly, I'm doing a clean-up pass with the back of the workpiece supported by this travelling steady. And it's taking a little bit of material off, so I think it's probably going to be quite helpful. Oh, let's see how we go. Sorry, it ran out of picture there. I apologise for that. Well, hopefully there's enough there that allows you to see what was actually happening. So let's pull it all apart and check the nut again. Right, well that travelling steady seemed to fix the problem, and I can run the nut freely on here now. I've just got it held with a wooden spanner which will shear off if anything nasty happens, but it does run freely now. So I'm guessing you could probably see there was a little bit of run out there, but in this application that won't be any problem because the screw will operate always in tension. It's not a pushing screw, it'll only be pulling both ends together. So the fact that it's got a slight bow in it is neither here nor there. Right, well, let's finish cutting the male thread. Now I've got to make a nut to go on that, and based on the original, it's quite a decent sized barrel nut. I don't know whether I mentioned or not, but the original I'm copying was Imperial 7/8 14 TPI, and I've made 22 1.5 metric equivalent. But I've got to make one of these with a thread to suit that. This was just a nut I bought to make sure I got this thread on size, and then I'll make this nut to fit that. And the other thing I've got to do is make a head to go on this bolt, and so I'll put another piece of scrap rod turned down on there and hold it on with Loctite retaining compound and cut a 34mm hex on, which is about what this is. By the way, the nut is a pretty good fit on the thread. It's not loose and sloppy, but you know, it's just a really nice snug fit. I mean, this thing would have just sheared off if it jammed anywhere. So I've cleaned up a bit of scrap, and that's going to become the head of the forcing screw. So I've got to bore that to match that diameter and stick it on with Loctite. So we'll part this off to 20mm long. I think it's time to increase the speed a little bit. Right, next step is to mount this piece in the chuck and bore him out to fit the end of the forcing screw. I have to say, it's very satisfying seeing a piece come out like this from a bit of scrap that looked like that. Very satisfying. And that's certainly starting to go on. I don't know whether I'm happy with that or not. Still, I was hoping to get a bit of a slip fit. I suppose Loctite will still getting all the little bits. Let's see if we can get it just slightly bigger. Let's get this guy on. I've cleaned the bits up with brake clean. Now, time to goop it up and hope that Loctite can 648 can do its magic. Get some inside this guy as well. Try not to get myself all messy with it. Perhaps forlorn hope. Here we go. Right, that should do it. Well, I hope it will anyway. I'm going to clean myself up a bit now. It hasn't grabbed just yet, but I think it's just starting to. Alright, so I'm getting ready to make my version of this big barrel nut. The material I'm going to use is another salvaged hydraulic piston rod. Interestingly, with this one, I cleaned the end up and you can see, I think fairly clearly, you get a pointer, the boundary of the induction hardened area. So there's a very thin layer of chrome, only 1 or 2 thousandths thick probably, and then this area that's been induction hardened. So I'm going to strip that down to what we'll call the core, and then it becomes quite easy to get to the diameters that you want. Well, the tip I've got in there at the moment seems to be coping with this setting. I've got a millimetre depth of cut and a feed rate of 0.22 millimetres. It makes a fearful racket, so I've got earplugs in. but it seems to be stripping it off. I'm sorry, I just realised I've been calling that a millimetre depth of cut when it hasn't been. It's been a millimetre off the diameter, or half a millimetre depth of cut. But still, we're getting there, and it's made good inroads into the hardened layer. Well, I think it's breaking through the hardened layer here. The one more pass and we'll be there. Right. Well, I think that's got clear of all the hardened material now. So it is a bit of work machining this stuff to get it to a usable point, but I get it free. So, you know, a piece of 4140 that size is worth a few bob. This will be the final pass on this, bringing it to 38.1. The 38.1 isn't critical. Tiny little bit either side won't matter. Well, it's pretty hot at the moment, but hot is on 38.13, so that's fine. Right, now I've got to chop it off. I might stick a hole through it first, make it easier to do the parting operation. I think that guy will be rather warm, so we won't burn our fingers. Righto, so I'm set up to cut the 22mm thread. Might be time for the first try. That pass was on 21.9. Thinking about it, but not yet. I think we'll run this one back through at 22 again. It's getting close. I think we'll go at 22.1. Because it's a fairly fine thread, the difference between good and really loose isn't so much. Anyway, we'll go at 22.1. I think we'll be getting pretty close. Look at that. I'd say that's perfect. I've just got to do some chamfering now. Right, so I've got this beast mounted now, and I'm going to cut 6 flats for a spanner. Right, I'm going to do this in 2 passes. I think I need to take 2mm off basically on each face, but I'll go all round with 1mm first, and then I'll be able to check to see exactly what I've got. Well, that 4140 is tough stuff. I think this will be the last side for this setting. It certainly looks like the Loctite's holding, doesn't it? Okay, here we go for the second pass to bring the across the flats down to 34. So we're taking about another millimetre off each of the faces. So I'll take it out and check that I've got 3 sets of flats that measure 34 millimetres across. That's one pair. 33.94, well that's good enough for a spanner flats. 9.5, I think the others are all pretty much the same. Yeah. Anyway, as I said, good enough for spanner flats. So you might recall when I was turning this thread that the act of turning the thread seemed to release a lot of stress within the bolt, and it started to try to revert to banana shape. And I think you'll see here that it made a good effort at that. So that's a significant run out that came in just because of cutting the thread and releasing the stress. So I might have another go at pressing some of that out, but it won't interfere with the operation of the thing in its intended application. So I'm set up here to cut some flats on this nut for a spanner. The size doesn't matter that much. I'm aiming for 34 millimetres across the flats, but it's going to be adjustable spanner to drive it anyway, so it's not that fussed. Anyway, this is pretty tough stuff. So I'm taking 2 millimetre skims off to create the flat, and I'm doing it in 3 passes: 0.8, 1.5 and 2. And it puts up a fight, but the cutter seems to be up to it. So let's get to it. Just noticed my support pieces fell out. Not happy about that. I'll get them back. I'll just have to do the vise up extremely tight. Alright, let's try again. So hopefully we'll be somewhere near 34 millimetres across the flats. .3409. Well, happy with that. Right, let's rotate it and do the other pairs of sides. So we're on the home straight now. This is the last side. I've done the first cut at 1 millimetre deep, and I'll do another 0.5 now. I'll do a final size check before I set for the final pass. And the final pass is a further 0.5. And by the way, this shim stack down here tries to walk out from underneath the job, so I'm just holding that in place, keeping my fingers well out of the way of that beast. So we'll just check that final cut, and hopefully we'll finish up at 34, or a good representation of. Well, we finished up at 3401, so happy with that. It's like I said, it's always good practice shooting for numbers, but in this case they're just spanner flats, I mean, who cares. Right, but that's now given me 6 flats. Let's pull it out and clean it up. Right, well, here's the finished product. Barrel nut turns nicely on the thread. It does have some cutter marks on it. I think one of the teeth on the cutter was chipped. I didn't notice it when I was doing it, but when they started out I did these first. These faces turned out really nicely, because this is tough stuff to cut. Anyway, I also made a couple of spacers and heavy washers. These would have been part of the deal originally, I'm sure. Well, that's another job done, and this guy can join its mates, its new mates, there, and wait to be used, if ever. So the main point of this video wasn't so much making a forcing screw as sharing with you my experiences with working with hydraulic piston rod, and stripping the hard stuff off and just generally machining it. Anyway, I hope you found it interesting. Thanks for watching, and hopefully see you on the next one.